All right, Dave, let's go ahead and get in this. Take us from ground zero, no pun intended.
Yeah.
Take us from ground zero on flat Earth, man.
Well, obviously the Earth is round because this is the picture that you're not allowed to delete from Zoom. So
It's a beautiful picture, man. It's on my iPhone. How can it be false?
yeah. Um, so just real quick, and I know people that are into know flat Earth already. We're gonna do some 101 here. And the thing is, when you first hear about flat Earth, Brian, I laughed at it like everyone does because that's ridiculous. Everybody knows the Earth is flat. They've known it for 2,000 years when Aristophanes figured it out.
You mean everybody knows the Earth is globe?
Earth is a globe. See,
Yeah.
look how far gone I am.
You are gone, man. You're out of here.
If you Google flat Earth, this is what you get. These are the pictures, right? No flat earther believes this. This is flat Earth Society stuff. When you Google flat Earth, you end up at the Flat Earth Society. Or even if you listen to presidential speeches like Obama, he plugged the Flat Earth Society a half a dozen times. Disinformation, tiny bit of truth in there, a whole bunch of nonsense because they want you to go there. They want you to laugh at flat Earth and never look back again. And that's what really happens. So
I'm glad you're dealing with it in this way. So you're basically saying there are factions within those people who call themselves flat Earth, right?
No. These are a government-run site. There's no flat earthers that believe in the Flat Earth Society. It's been around forever, and it's to capture the mind of the weak people, of the weak minds.
Who are some of the names? Is Mark Sargent one of those? Or no. Who are some of these?
I don't know a single name. There was the president, like back in the days, when Johnny Carson was on, he had the president of the Flat Earth Society on, and he tells this crazy story about falling off the side of the earth, and he grabbed onto a rock and he brought the rock to Johnny. Right? This is all mockery. This is all to make you laugh at flat Earth. And I was programmed with that as a kid. I saw that and I'm like, wow, that's so silly. And then I never really thought about flat Earth again. So it did a really good job programming the minds of people.
Well, I think it'd be beneficial to identify some of those guys, because remember the History Channel did one where they went to a Flat Earth Society meeting. So none of those people who are in that Flat Earth Society meeting are telling the truth, or they're psychological operators, or what?
I'm not sure which video from the History Channel, but they have come to our conferences and stuff, and some of them have done good pieces. Nightline actually did a pretty decent piece on us. And then there's other times where we had they were making a movie, a full feature-length movie about flat Earth, and they followed Mark Sargent and Patricia Steere and a whole bunch of other people, and they went to one of the tests where Jaron from Jaronism was doing a laser test, and they edited this movie to make it look like we proved that the Earth wasn't flat, but none of that was true. It was all they sold it to Netflix. They kept all of the footage that proved that we didn't prove that, and it's all deceptive. It's all deception. So Netflix, the mainstream media, they're all in it. This is the biggest secret. For those of you laughing at this, this is the most important secret that the elite have, because without this, they don't have control of people's minds. This is the one thing, and we'll get into that after we really discover what flat Earth is. So getting back to this, we're not a disc in space. So what are we? We're a pond. This is looking straight down on the flat Earth. This is one depiction. This is, like maybe a little artsy, but this is the world pond. Antarctica is all of the land that surrounds the pond. It's not a continent underneath a ball. It's the land that surrounds it. Antarctica is the highest land on Earth. Okay. So if you, so where is it going? Antarctica is the highest land on Earth. All of the water surrounds all of the islands, all the continents, and all of the water is held in a container. Water needs a container. If you had a lake and you got rid of the sides of the lake, all of the water would disperse. A bathtub, get rid of the bathtub, all the water disperses. Large bodies of water at rest need a container, and that container is Antarctica. Antarctica is the shoreline that surrounds our world pond. It's over 60,000 miles in circumference. Okay.
Now, how do we know that? How do we know that right there?
Yeah. So here's the simplest way to prove that the Earth is a ball or flat. Either way, they tell us that the circumference of Antarctica is about 13,000 miles. So all they would have to do, take two planes, bring them over here to the base, refuel them, and then the planes take off with passengers. One of them goes this way and one of them goes this way, just follows the shoreline, staying just off the coast. And you have observers looking out of the right window on one plane and the left window on the other plane. Planes going 500, 550 miles an hour. About 9 hours later, at 6,500 miles, is that 9 hours? It's that's like 14 hours later. Sorry. They should meet on the other side. Right? Boom. You just proved that it's 13,000 miles around, because this is impossible on a flat Earth. But the last person, no one's tried it on an airplane, but the last person to try it on a boat was Captain Cook. It took him 3.5 years and he went over 65,000 miles. Okay. Well, the equator, which goes right around here, right around halfway between the center and the outside, is 24,901 miles around. Okay. If the Earth was a ball, as you go south of the equator, those rings should get smaller and smaller, but they don't. They get bigger and bigger. Okay. It's so clear that that the Earth is not a spinning ball. I mean, for a million reasons, we'll get into it, but there you go. That's how, that's the easiest way to prove it. Question?
Okay. No, let's go to what's your next next one.
So you made some comments last time you were talking about flat Earth. Like what is the number one thing that keeps you from thinking that the Earth could be flat?
Me? Nothing keeps me from thinking flat or sphere. I'm right. Truly in the middle. I'm truly in the middle.
Right. So let's talk about, we'll go right into circumnavigation. I think that's always a goal. When people go, what about circumnavigation? You could leave New York and end up back in New York by just traveling west. And as I look for my illustration here, where is it? East and west are circles around the flat Earth. If I could find it, because
while you're trying to find that, I mean, yeah. One of the things that would pop up first in my mind is phases of the moon. What is the shape of the moon? Is it spherical? Is it flat as well? And we just see one flat side of it. Is that how it works?
Let's talk about that. All right. So at the flat Earth, you have the magnet as the North Pole at the center, and I put my compass down, and that needle always has to point to the north. So I'm trying to push this thing west, and to make it continue going west, or now I'm going east, I have to keep turning to the north. I have to keep correcting to the north to maintain that heading of 90 degrees, right? So So east and west are circles on a flat Earth. So I could leave, California, head west, go all the way around 270 degrees. I'm still going until I get there, or east. If I try to dead reckon in west, the second I start moving, I'm heading south. South is every direction away from the center. Okay. South, all these lines are south, heading away from the center. East and west are all the circles. Clockwise is west. Counterclockwise is east.
And that would be true of globe Earth or flat Earth, right? So any direction directly away from north is going to be south.
And east and west are circles on a globe. The problem, the difference that it makes, and this is one thing that's hard to prove, hard to do the test, because those circles get so big. Like when you're going from dead reckoning east, you don't even notice that you're turning because it's such a big circle. Like if you were on a track that was 1,000 miles around, that was a perfect circle, you'd think you were driving straight the whole time.
Right.
Okay. So the thing is, you always have to, whether you're going east or west, you always have to correct to the north. On a ball, as soon as you crossed over the horizon or over the equator, you would have to correct to the south to maintain that direction. But we have testimony from ship's captains that, are trying to dead reckon east or west in the Indian Ocean that say they always have to correct to the north. Okay. You can, the ballers will say, well, that's currents, the winds, you don't know that, the rudder was crooked, but again, these corrections are so minor. That's the hard part, is the understanding that you're actually turning. You with me?
Okay.
All right. So you were asking about the shape of the moon. Here's the question.
The shape and phases, okay. Wait, let me ask you one question about the characteristic of the moon. Is it truly self-illuminating, or does it get its light from reflection from the sun?
So what do you think? I mean, when you look up at the moon, they show us the moon as a dusty, dirty ball, right? When they showed us the astronauts on it, this is a dusty, dirty ball.
Mhm.
The inverse square law of light, which I'm not going to get into, but basically as light travels, every time it doubles its distance, it's a quarter of the brightness. So for the moon to be bright enough to read by in the middle of nowhere on Earth, it would have to be brighter on the moon for that light to get there. It would have to be, the number is so ridiculous how bright it would have to be for us to see it this bright, but let's just ignore that.
And the reason you're saying that is because what's taught in globe Earth is that it's 238,000 miles away, and if indeed it was reflecting the light of the sun, there's no way that we could read by it. Is that the point?
There's no way you could even see it, but that's a whole nother thing.
Okay.
Yeah. So if you were, if you're reading by the, clear night, full moon, it's bright as can be. It's probably like 20 lumens, but let's just give the globe every benefit of the doubt. Let's say it's 1 lumen. Okay. You go halfway to the moon, it's 4 lumens. Cut that in half, it's 16 lumens. Cut that in half, it's 64 lumens. It exponentially increases. When you get to about 100 miles from the moon, the number is like tens of millions. It might even be billions of lumens. The number is so ridiculous. It would melt your face. There's no way you can film it. Does this look like this light? I don't think you could see this from 5 miles away.
Yeah.
Right.
So I agree. That's a good point. I had never ever considered that. So that's a good point.
Right. The other thing is, Brian, do you have any lights in the ceiling in your room that you're in right now?
Yes.
All right. So look at those lights and tell me how they relate to the shape of your floor.
How do the lights in the ceiling relate to the shape of the floor?
Yeah.
They don't. There's no relation to the light in the ceiling. And
all right.
The shape of the floor.
So all of the things that we see in the sky, I don't think they're spheres. The moon kind of looks spherical, but we don't know what the moon is. See these? Is this a sphere right here?
Looks like it.
Well, it was half a sphere. So how about this one? Is this one a sphere?
Yeah, I mean, they all look like spheres.
They look like spheres, but this one is not a sphere. It's flat. Okay. How about this one? Is that one a sphere?
It looks like a sphere.
It looks like a sphere, but it's a cup. Okay.
Okay.
So your eyes, are filling in your world for you. There's, your eyes kind of.
Now, I would agree with that, except the figures that you're giving me right here, I can only, because of the position of the camera, and I'm viewing it through the camera lens, can only look at it from one position. But I can look at the moon, and 3,000 miles away, somebody else can look at the moon and have a different perspective. So that wouldn't, that wouldn't be apples and apples, right?
Well,
there,
that's because you're thinking that everybody's looking at the same moon. I believe that the sun and the moon that we see are actually projected in here, and the way we see in this, looking through the atmosphere, you can only see so far. So we all see through our personal atmospheric dome. So imagine you and I were outside on the street, and you're 50 yards away from me, and we're both looking at a giant mirror, upright mirror, and the sun is setting behind us. Okay. So we send a third person up to the mirror, and I say, I see the sun right there. And they draw a circle around the sun with a Sharpie. And then they walk over to you. They're going to draw a circle 50 yards over on that mirror. We're both looking at the same thing, but in different positions, because it's more like a reflection. And the way I came across this was I was in Las Vegas, and I was sitting at the pool, and the sun was, setting. It was around 3:30 in the afternoon, 3:45 for those of you who think I'm signaling 33, but it was 3:30. And the sun was beating on the right side of my face. And I was like, man, I got to go to the other side of the pool so I don't just burn one side of my face. And the hotel was about 100 yards over to the side. And it was one of those mirrored hotels. And the sun at one point lined up with one of the mirrors perfectly. And it was beating on the left side of my face. And it was equally as bright. It looked the same, of course, because it's a mirror. And I closed my eyes. I said, if I didn't know which one was the real sun, could I tell the difference? And I couldn't tell the difference. The heat was the same. The intensity. So that kind of tells you that, things could be reflections. There's all, the direction of something in the sky. You don't know what direction something's going in when you're looking through different mediums. There's moisture. We think that the firmament is liquid, is water. So when you have we believe there's like a dome, which probably, if you follow the Bible, it's like a looking glass. When you're looking through water and bent surfaces, weird things happen. So you don't know what direction things are going. You don't know what way they're facing. So again, looking up at the sky to prove the shape of the floor isn't really a great idea.
So you implied, or maybe I misunderstood, that if I'm looking at the moon on the same night as somebody else 3,000 miles away, and I'm on a phone and I'm in New York and my friend's in California, I'm looking at the moon and he's looking at the moon from a different perspective. You seem to imply that we're looking at two different things.
Well, you're looking at them in two different places.
The same thing.
Yeah,
the same thing from two different perspectives. Go ahead.
From two different perspectives. And then when you take into the idea of a personal atmospheric dome, so you imagine a person sitting inside the center of each one of these things, and this little intersection point, that's where they see the sun. So it's noon here, it's afternoon here, it's almost evening here, it's nighttime here on the East Coast. And as you know, here it comes back, and the sun will rise. This is how the optics of a dome would work. So these are the different time zones, and you're all looking at the same sun, but you're seeing it render in a different place for you.
Okay, and then from your perspective and what you've come to believe based on your research, it's the sun and the moon that are moving, not the Earth rotating, right? That's how it's moving across the sky.
100%.
And if that's the case, under what power is it moving? I mean, what's causing it to move?
Yeah, so again, the sun and the moon that we see is I, for the lack of a better word, I call it a projection into our system, like a focused point of light. Like, remember when you had a magnifying glass and you would burn anthills when you were a kid? Don't tell me you didn't.
Mm-hmm.
I know you did.
Yeah.
If you focus that little point, and I encourage people to go get a magnifying glass and get the sun and focus that point and look at it. It literally looks just like a sun. But if you lifted it up 6 inches, it's not there anymore. But that focus point of light is still there. It's in the air though. Okay, so it's kind of like the dome, in my opinion, is the lens that's focusing this point of light. What is the sun? These are questions that are beyond, I think, humans understanding. This is, comes from source, whatever created this place. And it wasn't a big bang that created this place, was intelligently designed. So, the one of the big questions that people say is, when the sun goes out over over the Tropic of Capricorn, it has to go faster. Do you understand? Let me show you what the Tropic of Capricorn is and everything. Okay. It's going to take me a second here. You got another question while I fumble?
Yeah. Hopefully when we get off that, I want to go through the phases of the moon, because I'm just wondering what causes the waxing gibbous, the waning gibbous, and all that kind of stuff.
Sure. We'll talk about that in a moment.
Because from the perspective of the globe Earth, what causes the phases of the moon is the moon or the sun casting light on the Earth and the Earth shadowing the moon, right?
Correct. Can you see my entire screen here?
Yes. Yep.
Yeah. So this is my app, the Flat Earth Sun, Moon, and Zodiac Clock app. And so what it is it shows you the path of the sun and the path of the moon. They both make circles over the Earth. In between the inner yellow line, the inner yellow circle, which is the Tropic of Cancer, and the outer yellow circle, which is the Tropic of Capricorn. The sun is the hour hand. Right now, it's not attached to the hour hand because we're in what I call fake daylight savings time, right? And the sun it migrates in between these two tropics, 6 months in and 6 months out. Right now, it's almost over the Tropic of Cancer because we're heading towards our summer solstice, which is around the 21st. Let me jump forward a little farther. So here we are. We're in June. It's over the Tropic of Cancer, and we're having our summer. It just went over Miami, Florida, Mexico. Super hot there. Okay. But at the same time, Australia is having their winter because the sun is farther away. It's out north or inward north. But if I jump the sun forward 6 months, Australia has their summer and we have our winter because the sun is over their head, higher in the sky.
Okay, so how does the sun make that transition further out from the center? How does it do that?
So whatever the source is, if you were and so also when it's going around, it goes around once every 24 hours, but it's making a bigger circle here, so it's going faster. So here's all I can say is, if you stand, let's say you're standing up and you got a flashlight or a laser beam, whatever, and you're pointing it out 4 feet in front of you, and you you start turning around in a circle. Let's say you turn around once in a minute. So you follow the path of that on the floor, and that draws a circle. But then you point it 6 or 8 feet away from you, and you turn around at the same rotation, same speed, 1 minute in a circle, it's making a much bigger circle. So how did it speed up? Well, it really didn't speed up. It's the same. You're spinning at the same speed, but its focal point has changed. Again, these are things, Brian, things above our head or things beyond where we're allowed to go in Antarctica, we have to speculate about. But if you really want to understand that the Earth is flat, you don't have to go there. There's stuff right here in front of us. So let me show you this real quick. So right now, this is showing about a half moon. Well, it has a relationship to it. The moon's phases do correlate to the position of the sun, but they don't always line up perfectly. But I think that the sun is part of the battery that powers the moon, right? And so if I speed it up here, you'll see that the sun will catch up to the moon. It laps the moon once every 28 days. And as it gets closer to the moon, it's waning, getting smaller and smaller. And when it catches up to the moon, we go into a new moon for almost 2 full days, and then you can't see the moon anymore, right?
Mm-hmm.
And then it'll start waxing and get bigger and bigger, and that's how the moon keeps track of the weeks and the months. The sun keeps track of the hours and the days, and the stars, which also this proves that the Earth is not a spinning ball in a beehive heliocentric galaxy. Is the stars actually lap the sun once a year. Okay, so right now the sun is creeping into this zodiac, and the zodiac will slowly outrun the sun in about a month, and then come June 21st, it'll go into. Well, actually, we're in a different month, but the following month it'll go in here. If I turn that off, let me just let the sun reset. There we go. So right now we're going into the Tropic of Cancer. Where's the sun? Right here. Yeah, so right here, it'll be in here for a little while, and then it'll move into the Tropic of Cancer, and the stars will lap the sun once a year. So that's how the stars keep track of the seasons and the years. The sky is a perfect clock.
Okay, so let me ask you something while you have this map up. Yeah, I'm glad you took the zodiac down. Say you have somebody, okay, if you got a guy on the southern tip of Australia, the southern tip of South Africa, and the southern tip of South America, and they're all looking south, they're all looking due south, everybody sees, pretty much the same stars in the sky, give or take.
Absolutely.
They may be in different, like a different perspective, but it's the same star cluster. How can that be on the flat Earth model? Because I understand it with the globe Earth, but how do you make sense of it with the flat Earth?
So it makes perfect sense, actually. So let me turn off the time zones. If you have somebody here, and you can see my mouse is very small.
Yeah. Mm-hmm.
Somebody here in South America looking south. South is out, away from the center. Somebody here in Johannesburg looking out. South is away from the center. And Australia, south is away from the center. Mm-hmm. So the stars spin around, right? So I'm going to turn the stars back on, and I'm going to turn them. So right now, this guy in South America looking out, he's seeing these stars, right? And then the sun is setting, going away. And at the same time, later at midnight, midnight is right here, okay, for South America. Mm-hmm. So boom, they're looking out, they're seeing the same stars. 12 hours later, somebody in Australia is going to look out and see the same stars, because when it's noon in Australia, it's midnight in South America. And then
but you're talking about, I'm just talking about seeing the same constellations at the same time, not 12 hours
they
later.
Don't see them at the same time.
They don't
see them. No, they don't. They see them at midnight. Let's say at midnight, they look at the Southern Cross in Australia.
Right.
Okay. Well, midnight isn't for 12 hours later in South America, and the Southern Cross will rotate around and go right into that midnight position. The stars all rotate around at almost the same speed as the sun. So now there is times, like, let's say the Southern Cross is here at midnight off of Johannesburg. Well, somebody in South America might be able to see the Southern Cross on their horizon, and somebody in Australia might be able to see on their horizon, on their opposite horizon. but they don't see it at the zenith at the same time.
I get it. Hey, let me take a real quick second. Okay, so people in the chat room, I understand that people can get really passionate about this. Here's the thing. I don't know what to believe right now, right? But I am going to open myself to any potential truth because that's just what people do who lack knowledge. I can't sit here and claim that I have all knowledge. I can say this, and I hope we get into this, Dave, about the lies of NASA. You know, I have to take into account that NASA lies. I have to take into account that they're using cables. I have to take into account that they're using green screens and all that kind of stuff. And I also have to take into account things that I know or don't know about flat Earth. So I think the best takeaway from this whole thing, guys, is that we just, whether we agree or disagree, we're all fellow human beings trying to figure all this stuff out. Let love and kindness and compassion prevail. We may walk away from this thing not changing our minds at all, but one thing I know we're not going to walk away from is stop being human. So if you guys could just do me and yourself and the human race a favor and, you know, agree to disagree in a kind, polite way, and let's fight for freedom and truth and decency.
Brian, I make it fun for those people that are triggered and think it's the dumbest thing ever. Well, that means you're pretty confident that you live on a ball. I'm offering 2 Bitcoins to anybody that can come up with one proof of the globe, right?
Yeah, and in the meantime, guys, I mean, I really think we can go about this thing with sincere hearts, because I believe people who champion the cause of globe, you know, most of them, I'm just giving people the benefit of the doubt, are sincere. I believe Dave and people who champion the cause of flat Earth are sincere. Could either of us be sincerely wrong? Yes, but that's where evidence comes in. That's where dialogue comes in. That's where conversation comes in. So I'm not going to beat this dead horse, but hopefully we can do all this in an adult manner where we walk away loving each other just as much as we did when we came into the room. So that's my say. Okay, let's go on to the next thing,
real quick, and then we'll get into NASA and some other proofs. But if you Google, just like, you know, looking for information on health and stuff, you're not going to find anything that, you know, that the elite don't want you to find. So if you Google flat Earth, you end up at the Flat Earth Society. As I said, you end up with all nonsense. If you spend 500 hours researching flat Earth by Googling it, looking in YouTube, you're going to find maybe an hour's worth of good content. On my app, every day I have a daily video. On the bottom left-hand corner, you just click that thumbnail, up it comes. And I tell people, take the Flat Earth app challenge. Watch the video every day for 2 weeks. And if you still think the Earth is a globe, hit me up and with the proof, and you win 2 Bitcoins. But before you do, you got to hit that question mark on the right, and up come all of the questions. What about eclipses? What about gravity? What about seasons? If I hit what about eclipses, up comes a playlist of videos that Google will not serve you. They don't want you seeing these videos. And right here, the 2 at the top there are a video I made that show the projected sun, an actual where you can actually see it, and I'll show you how it works. Amazing videos right there that'll really show you what I was talking about. Also, tons of other information in here, mud floods, all sorts of stuff. My interviews, this interview will be up there on the top, second from the left on the top. Flat Earth books, if you're looking for good content, all sorts of stuff. That book features coming actually probably tomorrow. It'll be added to the app.
I'm glad you brought that up, because one of the things that I thought would really argue the case for globe Earth is the lunar eclipse. And then I saw a couple videos that you can see on YouTube where there's a complete lunar eclipse with both the sun and the moon in the sky, because the normal way of thinking about it, or at least the public school way of thinking about it, is lunar eclipse happen when the Earth gets between the sun and the moon. And how can the Earth get between the sun and the moon when both the sun and the moon are on the horizon? So that's another thing that makes you scratch your head and go, wow, what I thought I knew, I guess I don't know.
Yeah, that's called a Seleninian, if I'm pronouncing that correctly. Yeah. I always get it wrong. Yeah. And there actually was one, there's well over 50, but there was one just the other day that happened, and the best viewing spot was in Canada. And I'm just wondering, we were trying to get some people to film it. I'm not sure if anyone got it, but
hey, Dave, Living Soil asked in the room, how can I buy this app? Where can they get it?
The app is called the Flat Earth Sun, Moon, and Zodiac Clock app. I'll show you where to get it in a second. But in the app, I'm trying to move things around here. There's in the video section here. If you want to just scan that QR code, there you go. Just point your camera there. But I'll show it again in a moment. I don't want to just hang here. I'm not here just selling apps. I'm here selling information to verify for yourself. Don't believe anything I say. I'm just showing you some things that you've never seen. But you know, this is my favorite one to show. This is the NASA's moon lander. Look at this thing. This thing is made from paper mache, tinfoil, curtain rods,
duct tape, baling wire.
I don't even think they use duct tape. I think they use like masking tape. Okay, it's horrible.
It's just ridiculous.
It's absolutely ridiculous. You know, here is them practicing in their pool. Okay, and that's what they show you on the bottom. Right? It's crazy believing in the globe. The globe is just completely ridiculous. NASA, here's an image. They have this panoramic image. Looks like they got lazy with their Photoshop, with their cloning tool, and they use the same thing twice. Right here.
Oh,
what are the odds? What are the odds of that?
Right.
Okay. So that's called the Flat Earth, Sun, Moon, and Zodiac Clock app. Just read the reviews. It's $3, guys. $2.99. That's how you support me. There's a pop-up that says, would you like to subscribe? Because people ask for a donation button. You're not allowed to have a donation button. You don't have to subscribe. You can just exit out. There's no ads. There's no wait time. It pops up once a day. Exit out. You still get everything. So read the reviews. It's the highest rated app in the App Store. Oh, for Google Play, for Android phones, you have to have 8.0 operating system or higher, right? And an iPhone, you need a minimum of an iPhone 6. And
what happens if they don't have that minimum? They download the app. Does it just not work right, or not?
It won't download. I don't think it'll on Google Play. It won't even show up if you search for it. So it won't show up that way. So well, where are we going? You asked.
Real quick in the room. If you guys have a question for Dave that you want fielded, like say you're pro globe or whatever. If you have a question for him and you think this is going to stump Dave, ain't nobody got an answer to my question, honey. If you got something like that, put it in the room and let's field that. Let's go over some NASA lies, because I think it's really important for people to understand that NASA, we tax cattle are fleeced to the tune of $60.1 million, not a week, not a year, not a month, but every single day, and show some of those NASA lies that we get for our money.
Right. So originally we had a maybe it was a Voyager that went by Saturn, and you can't really see it, but this is the famous picture of Saturn up here. But they didn't expect us to have Photoshop and be able to take this off their website, crank up the levels, and you can clearly see this thing was put together like a sixth grader's collage. Okay.
And how old is that image of the Saturn?
This is the, I don't know what year it was taken, but this is like the best picture of Saturn that NASA has. This is in every textbook. Just look up photo of Saturn. This will come up.
And they're saying that's an actual photo, not an artist rendering. That's their claim?
They're saying it's an actual photo from a spacecraft, right? It's when you look at NASA, I mean, here's the thing. If you catch NASA lying once, that's enough to unwind it all the way to we didn't go to the moon. Yeah. Right? And just remember, when they show you themselves floating on the space station, this is how easy it is. Okay. And I don't get $61 million a day. Okay.
Dave, you know what's scary about that? You've practiced that so much. You're so good at it and convincing. I don't even know what to tell you, man.
Yeah. Well, it's, you know what? I'm so convincing because it matches the same green screen nonsense that they do.
Yeah.
So, where are we going? I'm looking for NASA stuff. Okay. So NASA fakes everything. So again, this is people said the big argument is, what about the Chinese? They'd rat us out. The Japanese, the Russians, right? This is the Chinese moon landing the other day. Not moon landing, Mars landing. Did you see that?
Yeah, but are they saying that's an actual depiction, or they're just saying that's a graphic representation?
That's what they do. They never say it's a graphic prediction, a graphic illustration, or that it's real. But this is what they show you. This is the only proof. And here, they're hugging. It has to be real.
Right, okay? Yeah. Emotions.
That is the only proof. Here's something they say is real. This is SpaceX launching what I call their grain silo, okay? Anybody that thinks this is real, the amount of thrust, this thing is millions of pounds. The amount of thrust that it should obliterate that little rack that it was sitting on. And look at this thing. This thing is a combination of a helium blimp, CGI, and a whole bunch of stuff. And notice, cut. There's just cuts. They never show you the same thing. Now look at this. You're filming it from the side. The higher something gets, look how high it is now. How are they still filming it from the side? Okay. And then watch, you're going to cut back. Look how high this thing is. How are they filming it from the side? Now this thing is going to fall back to Earth. There's nothing holding it. It's falling. It's still 50 tons or whatever the weight is. It's ridiculous. This thing is gigantic. Look at the steam, the smoke coming off of it. This thing is floating. The steam is just going off of a barely moving object. Look how high it is. And look at the side view. That's impossible. This is a movie. And then watch. This thing's going to all of a sudden fire up. Look how high it is again. Like they're out of sync, right? And this little bit of flame is going to flip this thing over and steer it right back to where it took from, okay? Who got underneath this thing? And now watch, 2 of the 3 engines go out. They say that's on purpose. I think just because their little CGI screwed up. Look at this thing. And then watch the CGI dust when it gets down close. Again, watch. Look, that's CGI dust. Did they forget to sweep the launch pad? Look at the thing. It's landing at an angle, but that's okay. Brian, you there?
I'm listening. Yeah, I'm here.
So anyone that believes that's real, well, you're what I call a NASA fanboy, and there really is no help for you.
Hey, while we're doing this, go ahead with your next
last
slide.
thing, and then you don't forget what you're going to say. This is something different. This is a projection, like Tupac was projected. This is a holographic projection. We actually were looking at photos from NASA, and we saw these weird lights on their lawn, and we zoomed in on them, and we got like a serial number or a name, and it was a holographic projection company. Okay, so. This is a holograph. Not hard to believe, with the technology that they have, Project Bluebeam, whatever it is, but it glitched out.
And that's their footage. You didn't do that. That's their footage.
Right. Okay. This is their footage. It glitched out. Okay. So, and again, you notice how they're always zoomed in. They never give you like one shot of a rocket. It's always cut. It's a mess.
So what about people at Cape Canaveral, 5 miles away or whatever they are from the launch? What are they seeing? What are they seeing when they're there in person? They're not looking at it through a camera lens or anything. Right. What are they seeing?
So that is mind control right there. Nobody is right there. So watch it. If you Google launch of the space shuttle, this is the video that'll come up. So look, that's guys are pretty close, right? Look at this little fence too. This fence would be atomized from the power of this thing. Superheated smoke coming out. Now look at these people. They're not there. These people are over 10 miles away. They're probably like 15 miles away. 15 miles away, that thing is tiny. Okay, you can't see what's going on. These people are nowhere near that. No one. So this is mind control, making you think that people are right there.
But don't you think don't you think people who are watching the news and it's like, hey, 5 minutes until launch, let's all go out in the backyard and have a barbecue.
Yeah, but nobody's closer than 10 miles. Nobody's closer.
But what are they seeing go up? Because
what they're seeing go up is a blimp. A helium blimp. NASA owns all of the large helium companies in the world and is the largest consumer of helium. That orange tank is a blimp. The amount of thrust to lift 4 million pounds would obliterate everything underneath it, right? This is smoke coming out of the ground. This has nothing to do with this. This is just to obscure. This is a blimp. The reason it rolls over is because the orange blimp is lighter than the rocket ship blimp. There's no people on this ever. And
how do you prove that assertion? Because people are going to go, okay, Dave, prove it's a blimp.
Yeah. So I have a series of videos, literally showing you all of these launches and how it happens. We actually have one rocket broke on the launch pad, and it just folded over, and you could see that it was a thin little blimp. But watch this, Brian. You can't hear the sound on this, but when these things blow off, when they, there's explosions that go and they blow off right there, you hear it and see it at the same time. This thing was well over 20 miles downrange, which means that the sound, if it could make it back to you, would take 90 seconds before you would hear it after you saw it. 90 seconds. So you're
saying these two capsules that just detach from the main thruster, are those blimps too?
No, these are I call them fireworks. They are giving some thrust, but look at them. You can't turn them off. How come they didn't just take off? If this thing's going 17,000 miles an hour, how did those things turn sideways and maintain that speed? Don't you kind of need to be aerodynamic? And if you look at the smoke, when I can't loop, has the loop. If you look at the smoke coming off of that thing, you can see that it's going maybe 50 miles an hour, maybe, but it's supposed to be going 17,000 miles an hour. You ever see a jet fly by, you know?
Yeah. Just go shoo.
And that's that's not even 1,000 miles an hour. Okay. This is a blimp. And again, here's another proof of that. After it drops, it falls back to Earth so fast that it atomizes and burns up. That's the official story. Does this thing look like it's falling back to Earth? This is the space shuttle. They're going into orbit and they're filming this, supposedly. Now watch right here. A piece of paper is going to go by, which is going to give you a reference of how fast it's moving. Ready? Here it comes. There it goes. Okay.
A piece of paper.
Did you see that piece of paper?
Yeah.
It was probably a tissue or a candy wrapper that came out of the helicopter that was filming this. Look at this thing. 40,000 pounds empty. And it's supposed to burn up before it gets to these clouds. I think this is under the clouds and they're just filming up and they're just telling us it's falling. And there goes another piece of paper.
Yeah, I saw another one. Yeah.
Yeah. So you have to believe
where are they saying this canister is? How far up are they saying that is?
So the rocket took off. It went higher than I showed you on that other one. It gets rid of that when literally it's going into space. So is that 80,000, 100,000, 200,000 feet? I'm not sure of the height, but it's supposedly falling back to Earth and it's going to burn up. When is it going to start even smoking? Right? It's pretty darn close to those clouds. And part of the mind control is one of the things they do when they had the space shuttle program, they would get the fuel, this big tank, and they'd put it on a giant truck and they would parade it through a couple of towns, and they'd have to take down telephone wires and, go a special route, not to go under any bridges. And it would actually be a metal tank and people could see it and applaud it. And then it goes there. And then that's not what goes into space. What goes into space is just this blimp. This is a helium blimp.
Interesting. Yeah, when the Challenger made its way out of Palmdale, I think they made it in Palmdale, Challenger. They have a road there called Challenger Way. Yeah, and supposedly they paraded that thing down that Challenger road.
That's all mind control. I'll give you, Brian. Well, actually, if you go to my YouTube channel DITRH and just look through the playlists, and one of the playlists is Rockets Are Balloons. I have a series of about 7 videos there. They're also on the app. You could find them in there. Check those out and your mind will be blown. It's crazy. And for those of you that say, what about the Challenger astronauts? Brian, you've seen the videos of them still alive, right?
Yeah.
Mm-hmm. Yeah. So they all had identical twins that had the same name, and none of them showed up at their sibling's funeral. Okay. That's enough said about that.
Yeah.
Right.
Okay. As long as we're talking about fake NASA stuff, I don't think a lot of people have seen the lunar lander with Buzz Aldrin supposedly and Neil Armstrong in it take off when the camera left on the moon. The cameraman left on the moon is actually following it up. Do you have any of that footage?
I have this footage here of after it took off. Actually, this one might show it taking off. This is a spaceship, right? This is it coming back to meet the rover, to meet the orbiter, right? There's 2 grown men in here, okay? This isn't even the best video. I got to find the other video. There's one where it just literally is moving around. It's like the worst model ever.
And just for clarification, this is supposed to be real footage per NASA, right?
Per NASA, right.
Yeah.
Here's just an analysis. I know which one you're looking for, which shows the whole thing where it pans up and follows.
Yeah.
Okay. But there's so many things wrong with this. It's unbelievable. So
what is this right here? Oh, that's the Apollo 16 taken off in 1972. Okay.
Right. Here is the astronaut supposedly on the moon, and he drops his hammer. Now, this guy, I believe he's got wires on him hooked to a giant helium balloon that's just making him light, so he gets to move around, and it's not like a big crane following him, and he can't reach down and get the hammer. He's trying to get some momentum to get that balloon down. He can't do it.
Yeah.
Bizarre, right?
Yeah.
Here is everyone's like, this experiment here proves that we're in space. This is Chris Hatfield. He's wringing out a napkin, and all the water, a paper towel, all the water is going over it, is hanging around it. But they did the same thing on a zero-G plane, and it worked the same. And if you watch the video of him doing this, there's like 15 cuts because they had to do it in like 15 parabolic arcs.
Right. And in other words, the plane had to do its descent and then make altitude again, and then do its descent.
Yeah, and then they just do it. They film it a whole bunch of times, and they edit it all together, and they try to remain in the same place. It's unreal. Here's one. This is one of my favorites, which I recently added. Is they had a fresh lemon that came up on the Soyuz or whatever craft that brought it up, and you can tell it's not real. It's an augmented reality. They're manipulating objects that aren't there. You see that?
His hand is kind of translucent and transparent.
It goes right through it. Look, his finger goes right through it.
Yeah. And
so it didn't work so well, and they didn't catch it. Now, either they do this stuff on purpose, or they're kind of just letting us know. I'm still on the fence about that. This balloon is real. It's filled with helium, and it's just neutrally buoyant. This is fake. Watch. I'll show you again. It's not there, and now it's there. And now she's manipulating it. It's called augmented reality, and they're manipulating not real objects. In the movie Gravity, they show how they did it with the green screen, and she's like turning a knob that's not there, and then they show you in the movie there's a knob that she's turning.
Right.
It's crazy. Here is this is both of these are on a zero-G plane. This one just looks like the space shuttle, like the ISS, and this one's not. Right. And they're just showing you that's how it works. This was live on the morning news show. And during the broadcast, all of a sudden they said, we only have like 45 seconds of satellite time. Interesting. 45 seconds is about the time of a parabolic arc. And in the middle of it, all of a sudden they slammed into the wall. They just slammed into the wall, and they cut away, and they're like, oh, there was some sort of unexpected shift in the space station. Well, I turned it on its side. I compared it to the end of a zero-G parabolic arc. Looks a little similar, if you ask me. So these guys were ready for this. Like, this guy catches this object with one hand, like he's done it a million times. So there's no doubt that is a parabolic arc on an airplane, on a zero-G plane.
Okay, go ahead. Go ahead.
No, go ahead. Ask a question.
No, I wanted to see the cables. You just went to it.
Yeah. So this guy is way down the hallway. You barely see him float by, but it's just for mind control. And they didn't expect anybody to go zoom in and see. You can almost see the cable here. On the original one, you can actually see the cable at a couple points, and you could see his harness, and you could see that he's clearly hanging from a harness, right?
Yeah.
These guys are flipping their microphone around and flipping this fake CGI hat around. He's got his baseball cap. And in the script, he's supposed to hand the blue hat to this guy, right? And so they have to remember the script because they're moving invisible objects around. And he accidentally moves his hand. And this guy thinks it's a pass off. Watch. He moves his hand. He thinks that's the hat. And he takes it and he puts it away.
Oh, right? Man. What?
Yeah. And then he's like panicking. He's like, what do I do? And then if you look at this, I'll zoom in on this guy's face. They were both freaking out. They were stuttering, and they didn't know what to do. And they just had to cover it up and keep rolling because this was televised live, I guess.
Wow.
Yeah.
Yeah. Like, why? Just from the outside looking in, why would he even make that kind of movement? It makes no sense.
No sense whatsoever.
Interesting. I've never seen that one.
Yeah, that's I mean, there's so many. I mean, this is just, people don't understand how well good green screens are. This truck doesn't exist. It's not there. It's all done in green screens. You can do anything. So that's pretty.
Okay. So while we're on NASA Lies, can we talk about Don Pettit and I'd go to the moon in a nanosecond, but we lost the technology? I think a lot of people haven't seen that either.
Well, I don't have that clip, but I mean, Don Pettit basically, when he was asked, how come we're not going back to the moon? It's because we lost the technology, and it would take it would be painful process to build it back again.
Yeah.
Well, here's Don Pettit showing us how to drink coffee out of a plastic sleeve that he made, right? But something went wrong. Like the coffee is CGI, and all of a sudden it gets out of sync with the plastic that he made. Okay. So he's probably doing it on a zero G plane. So it really was floating, but then they augmented reality, put the coffee in there. Right. And then there was some clip later where they showed where he made it with brown tape. They're like, it wasn't the coffee, it was the tape. Well, how does the tape become unsynced with it? Right. Yeah. We catch them all the time, and then they have to backtrack. They try to make make stupid excuses. Like one time, the Super Bowl was going on, and the people on the space station had the jerseys on. They had the 2 jerseys on, and there was a very weird scene there where actually when they did a flip upside down, they both flipped together, and when both of them were their backs were facing us, or one was upside down, one was right side up. The numbers, what was the number said? It was like was it 33 or was some weird number? It was some number that meant something. But the thing was, we looked at it and we said, wait a minute, how did they know who was going to be in the Super Bowl? Because the last supply strip up was 6 months ago. Okay. So that started going viral. And then all of a sudden NASA comes out with a video showing them the unpacking of the box 6 months ago with every jersey in it. Okay. What are the, I mean, think of the cost and the space to send up every jersey of the NFL into space. Right? Yeah.
Of course, they can afford it with $60.1 million a day, huh?
Yeah. So here's one of my favorites, Chris Hatfield. This is not done on a zero G plane. These guys are in green screen studios. They're not even together. And the guy in the bottom misplaces where Chris is, and he sticks the microphone right into his neck. And again, this is another one where they panicked. They're like, they quickly, they were just trying to distract. And it's clearly they're in a CGI studio.
And so the takeaway from this, for people who are watching, I mean, it's pretty obvious, but if NASA just lied just once, it opens the door for, first of all, why the heck did you do it? If all this is real, that would be completely unnecessary. Second of all, if you did lie once, how do we know you didn't lie 2, 3, 4? How do we know you're not just a bag of liars?
They're just a bag of liars.
Yeah.
I'm sorry. There's no, I showed you that one already. There's no other way about it. Check this out. This guy's head is transparent. You can see the thing on the wall. That's because this is done in a zero G plane, and there's no right-hand turn on a zero G plane. So they have to make it look like he's coming from around the corner. So they faded him in. These things happen all the time.
So now, of course, NASA lying does not mean that we don't live on a globe Earth.
Sure.
But that is one head scratcher that makes you go, if the people who are telling us it's globe Earth are lying to us about the visuals that they put before us on television, how can we trust them with anything? Go ahead. What were you going to show me on that?
This one, space station. Again, they got another ball that has helium in it. It wasn't quite balanced, so he dropped it and it fell. And then everyone was like trying to get it. And they're like, no, just leave it. Don't pay attention. They're like, just let it go. So just another little thing. One time they were working in the bathroom. The guy was trying to get a screw, and he dropped it and it fell. And he heard it hit the ground. And he's like, oh, and he started looking for it. Why did it fall? NASA's answer was, they hit a pocket of gravity. A pocket of gravity.
No way. Are you serious?
You got that gravity.
You got that documented? Really?
I'm sure it's somewhere. Someone's got it.
So what you're saying about this ball right here is it should have floated up. It shouldn't have gone down.
No, it should have just stayed neutral.
Yeah.
It should have just stayed neutral.
Right.
And again, listen, if I was on the space station, I went like this, I would go tumbling, corkscrewing through the space station. But these guys are hanging from waist harnesses, and they're trying to hold themselves, right? Look at these heavy duty pants. What's underneath their pants? Where do they get these pressed pants all the time, and these shirts that are always buttoned up too high? Okay. they always have different shirts on, different pants on. Where's their wardrobe up there? Okay. They always have nice, crisp, sharp clothes.
Mm-hmm.
Okay. And why are you wearing an industrial belt? Is your pants going to fall down in space? Right?
Interesting.
Yeah.
All right. So what are some of this is the proofs to the negative. What are some more proofs to the positive to convince a globe earther that,
Sure.
hey, you should take a look at this?
So when you go up in an airplane, or no matter how high we send something up, the horizon always appears to be at eye level. Actually, sometimes you can't even see that far. So the horizon will look to drop. Like this balloon, there's no way to prove if this is at the level of the camera or not. But I just believe that the actual horizon is out here. You just can't see it because you can't see that far through the atmosphere. But one of the things is, if you're in an airplane, next time you're in an airplane, Brian, look out both side windows, the other opposite sides, and you'll see the horizon at your eye level. Okay. This is a video that was on the app today. If you're flying at 39,000 feet, if you use the globe Earth curve calculator, you should be able to see the horizon at 242 miles away. Okay. So a 6-foot tall person standing at the edge of calm water should see the horizon at 3 miles away. At 39,000 feet, it's 242 miles away. So according to the Earth curve calculator, from the spot of land below the plane to 242 miles away, there should be 39,050 feet of curvature. But you have to add that to the height of the plane, which is 78,050 feet of drop. So the horizon that you see at your eye level, according to globe math, should be 78,000 feet below you. That's higher than the U-2 spy plane flies.
Mm-hmm.
Okay. But when you look out, you see that horizon right there. Eye level. It should be almost 80,000 feet below you. Okay. 80,000 feet like this. This is like 80 to 100,000 feet, somewhere around there. This might be around 100,000 feet. But that's impossible. When you think about that, it's just absolutely impossible.
Are you saying this image behind you, is that real image, or
this
is that
a
CGI?
balloon? Yeah, this is a balloon I think this one is at 120,000 feet, but look at the sun. It's right there. It's right there.
120,000 feet, which is how many miles? 52,080 divided by 120,000 feet.
So that's 20 some odd miles, 22, 23 miles.
The reason I'm asking if that's real is because I don't know if you're going to show this in your clips, but remember that rocket that hit, it was going fast and then it hit something, like it stuck into something. How high was that rocket when it hit?
The Go Fast rocket went 73 miles.
73 miles, which is more than 120,000 feet, right?
It is.
Okay. So what you're saying right there is that you're seeing a plain Earth, and the sun that you're seeing right there is not 93 million miles away, right?
Does it look 93 million miles away, Brian?
Well, I don't know, because perspective is everything. So I'm just I don't know what it looks like to me, because I couldn't gauge what 93.
I agree. No, that is absolutely, honestly, the only thing. We can't say how big or how far something is unless we know how big or how far it is.
Yeah.
Okay. So let's look at that. Let's look at that, and then I want to show you why people think they see curvature. Don't let me forget to show you that. So if you look at the model of the Earth, the sun is this giant ball, and the Earth is a small little pebble next to it, right? Little tiny thing. So if the sun was literally a mile over your head, it would fill the entire sky. You look up horizon to horizon, all you see is the sun. Then you move the sun 93 million miles away, and it becomes the size of a coin held at arm's length. Why is it getting smaller, Brian?
Because of perspective, things that go away from you appear
100%. And how much of that 93 million miles is our atmosphere? Not much of it. Very little bit of it. Very little. 10, 20, 30, 50, 100 miles, whatever you want to say it is. So 93 million miles of space, things do get smaller as they go away, even in space. That's my point. Okay. Brian, if I made it 24 times farther, do you think you could see it? How much smaller would it get? It went from the entire sky to the size of a coin. If I made it 24 times farther, scientifically, we can prove that you could not see it.
Yeah, I would say it'd be, if you could, it's a pinpoint. It's probably
Well,
not even
I
looks like
think
a
if you
star in the
doubled
night
the
sky.
distance, you couldn't see it. But I'm going to say
Mm.
24 times because that adds up to 3 light hours. 3 light hours, because 8 times as far is it's 3 light hours. Whatever. I think it's 3 light hours. It might be even less than that, but 3 light hours you could not see it. Now think about this. Polaris, they tell us, is 46 times bigger. So 46 times 3 light hours, 40, we'll call it 2 light days times 3 light hours is 6 light days. So if Polaris was 6 light days away, you could not see it. With me, the numbers aren't as confusing as it sounds. So I'm equating the size of Polaris that they tell us it is 46 times bigger. At 6 light days, you could not see it. And forget the inverse square law of light. It has to get dimmer and dimmer and dimmer. But ignoring that, 6 light hours, you couldn't see it. They tell us it's 433 light years away. 433 light years away. These are numbers that just most people are listening going, oh, how does he know the numbers? People have no idea what these numbers are. Brian, did I ask you this already? Do you know how long 1 trillion seconds is?
1 trillion seconds is, let me just guess, 34,709 years.
Very close. Very close. I always say 31,000. Okay. You might even be closer. 31,000 years. Okay. 31,000 years. The closest star, not even Polaris, the closest star is 25 trillion miles away. This is nonsense. None of that stuff you'd be able to see. All of the lights that we see are within the Earth system, not the solar system.
And all those lights that we see, you contend, are moving around us. We are not rotating and causing it to look like it's moving.
We're not moving at all. Everything's within the Earth system, and it's spinning around within the Earth system. That's the way I look at it. So getting back to the airplane, I'm going to show you a couple things that don't work on the globe also. But people say, I see a curve. Well, you see a curve because the way our eyesight works is if you're here at the middle point, you see the same distance in all directions, which is a limited distance, whether it's 6 miles or 600 miles, I don't care. Whatever distance you see the same distance in all directions. So that doesn't draw a straight line. That draws a circle, okay? Mm-hmm. You lay that circle down. Here's the limit of your vision at ground level, at whatever level you're at. The sky is higher. The sky will go farther because it's higher. And then if you draw a line across that, you see a curve. And that's not because the Earth is curving away. It's the limit of your vision, and your programming tells you that's a sphere.
Okay.
Got it?
Then while we're talking about curvature of the Earth, why do some contractors for long distance projects say that they have to take into account curvature of the Earth? Are they lying? Are they COINTELPRO, psychological operations? Why did they say that?
Or they're just ignorant and they just believe it. No one takes into account. Bridges, tunnels don't take into account. We've talked to submarine operators, and they say when they're down at the bottom of the ocean, they can see other submarines with their sonar. Sonar hits something and bounces back, right? Mm-hmm. And they can calculate things. They can see other submarines over 100 miles away. There should be a mountain over 6,000 feet tall between them. What does the sonar climb up and go over, hit the submarine and climb up and come back? Absolutely not.
Well, they were, the reason I asked is because, and this could be complete psychological operations. I don't know, but it says what happened when engineers forgot the Earth was round. They said Colgate University of California at Berkeley. Have you heard that?
No, I haven't. But
they had to build a 2-mile long vacuum pipeline that was necessary, that it would be completely level and flat. And they contend that they forgot to take into account the curvature of the Earth, and the project failed because they didn't account for that. So what is that? Do you want me to send you the link to that? Or?
You can send me. I'll take a look at it, but it just sounds like a bunch of nonsense, to be honest.
Okay. And the same thing unrelated was when they tried to build an accelerator in Japan. They did take into account the curvature of the Earth, and they said the project wouldn't have worked unless they did.
Nonsense. Accelerators are not what they tell us anyway. Those accelerators are doing something that we don't even understand. So again, there's accelerators that had a lot to do with 9/11. I have no idea what they're doing, but they were definitely tied to 9/11. The one out in near Montauk, I think it's called Bellhaven or something, and another one in Pennsylvania at the very strange Freemasonic place. Both of them were pointing directly at the towers. Just by coincidence? I don't know. Check this out.
Real quick, the let's see who said this. Somebody said that another thing that needs to be questioned is why, if all the why, I think, man, who was it that says this? Oh, Think for Yourself said, how can it be that we have all this space junk in the atmosphere going at 16,000 miles an hour and nothing ever hits the International Space Station? I've thought that as well.
Well, the global argument with you don't understand how big space is, and that's, that if you spaced it all around on the Earth, like, you would never even find any of the pieces. It's all nonsense. None of it's true. You can't verify any of it. None. They're saying that they're tracking all of this stuff. It's actual. I mean, once you look at it, it's insanity. I mean, think about this. Satellites are, they say that this is a map of what the satellites are doing. Okay,
I'm glad you brought that up. Yeah, that's exactly what I had in my mind.
So they're all going in different directions and whatnot. Okay, let's assume they're not going to hit each other, which is crazy. But think about this. Let's pretend this satellite is a geosynchronous satellite, which means it stays over the same point of land the whole time. Okay, Brian, tell me how that could stay over the same point of land when we're corkscrewing through space in 4 different directions at once. So the ball is spinning. It's got to match the spin. We're cruising in an orbit. It's got to match that motion. We're moving sideways in another motion. It's insanity. It's insanity to believe that. And these things they always just work, right? They don't break down.
Like in need of repair. So why? Go ahead. What was your thought?
When they push a satellite out of, satellites aren't weightless. They're just falling at the same rate as their speed takes them around the curve, which is just it's just a mind experiment. And it's just falling around the Earth. And because there's no atmosphere, it'll just keep on falling. That's ridiculous. But when they send these things out, what do you think if they push it in the slightly wrong direction or the wrong speed, the whole thing would just fall. It wouldn't. Yeah. But they never happens. Never happens.
I agree. The impossibility and all the geometry and all the physics and everything that has to coincide and come together and stay perfect, it seems like an impossibility. So why do they point anybody who installs a satellite for you? I don't care if it's DirecTV or internet satellite or whatever. It's always pointing south. What's the flat Earth response? Why are they pointing due south? Why is every one of them pointed?
Yeah, because they're pointed toward. Most of them are pointed towards cell towers. But don't get me wrong, they are using the firmament. They call it the ionosphere. They're bouncing signals off of this thing, or at least they used to. Because my father lived on the islands off of Puerto Rico for many years, and this was before. A lot of these satellite technologies were supposedly here, and he had a giant dish on his house, and we actually would move the dish, electronically, and it would point to what they called, 5 different satellites. It was just pointing to a different point of the dome where it was being bounced off of. They have GPS here. It doesn't work in like rural Kansas. It doesn't work over the oceans. It doesn't work between California and Hawaii. When an airplane goes from California to Hawaii, 100, 200 miles offshore, it's off radar. It's just in approximated mode, and it doesn't show up until it gets close to Hawaii. And that's because...
How do you know this? How do you...
Because you go to any... We had a professional... We have a pro flight tracker, and when you watch these southern flights, as soon as they get off of any coastline and they're not near any inhabited islands or land masses, they're in approximated mode. Also, over the Amazon, there's no the Amazon jungle. There's no GPS. GPS should go anywhere. It doesn't matter. It doesn't matter where the population is. It only works in certain areas. Now, there's people now that are getting these satellite phones. These things are giant walkie-talkies. I don't know if they're bouncing off the firmament or not, but there's certain areas that they don't work in. They're not satellite phone. They're not using satellites. The other thing is, you got to remember, maybe perhaps some of these communication companies are using NASA satellites. And when I say NASA satellites, I mean NASA satellites that are hanging from balloons, right? I told you NASA uses a lot of helium. And one of the things that they use helium for is their satellite program. All right. They launch these things from different places, but a lot are in Antarctica. And some of these balloons, Brian, are bigger than football stadiums. Okay. And they can carry, massive things into space, into the high atmosphere, because we don't believe there is space, and they can keep them up there for over a year.
What? Did they have to refuel the helium or what?
No, the helium's in there, and they can make it go up and down, and they go into different airstreams, and they can kind of keep it geostationary. Right. This one's being launched in Antarctica, and these things are up there, and they're crashing all over the world. We have videos on the "What About Satellites" button on the app that show you, they crashed, and people are filming them because everyone has a high def camera in their pocket, so this stuff is getting caught up, getting caught before they come and collect it. And all of these satellites that are crashing all over the world, most of them, if not all of them, have giant balloons attached to them.
So what you contend is that what these satellite dishes on the ground are pointing up to, especially over vast oceans or whatever, are these satellite, these balloon hanging satellites?
Perhaps they're using them, Brian, but out in the middle of the ocean, there's very limited GPS. The communications, I think that they're still bouncing things off of the firmament. So again, are they using these? Are they using, do they have aircraft up there that like AWACS aircraft that are relaying messages? Maybe, but it's not over a spinning globe. I mean, the whole idea of flying over a spinning, orbiting, whirling, corkscrewing globe is insanity. Most of the communications in the world are done through undersea fiber optic cables. This is a map of the cables that they tell us about. Okay.
That are under the ocean. Yeah.
They're under ocean at 99% or whatever the number is of the communications go on these undersea cables.
So TrueFX says, do you think we're like chickens in a chicken coop, not knowing what's outside, like the Truman Show? Is that kind of the idea?
Well, it is the True Man Show. And I don't believe, that this is it. There was a map that was found in Hawaii, a Japanese map from a few centuries ago, 10 centuries ago, that showed all of these other continents outside of Antarctica. What's that about? Okay. This could be other lands. They have us in here, and the people that took over since the reset in the 1800s, they decided to hide the truth of our world from us. They don't want us seeing that there's more land. Maybe it's set up something like this. Okay. Where there's another sun and moon system out here orbiting. And we're here in the inner space. These extraterrestrials, extra land is in the outer space. NASA's not lying when they say they want to go to outer space. They're not lying when they say extraterrestrials come from outer space.
If you guys have any questions in the chat room for Dave while we got him here, lay them on me, and I try to field them for you.
Let me,
Dave, what's the next thing you want to show us?
I want to talk about what about circumnavigation, because we talked about east-west circumnavigation, but what about southern circumnavigation? And not too long ago, there was a guy that was going to fly from pole to pole and circumnavigate the world, and I think it was called the ZQ pilot. And he went from the North Pole to Alaska to Hawaii, to California, Hawaii, Philippines, wherever this is, over here, Santiago. And then he went to the South Pole, supposedly. And he said the weather was too bad. So he turned around and took this route back through Brazil, East Coast, and back up. And we're like, all right, well, he's not going to get the world record for circumnavigation because he had to turn around. He got the world record. Guinness Book gave him the world record for southern circumnavigation, which is impossible on a flat earth. This is all he did. He went here, He touched the goalpost and then he turned around. That's like me saying my road is straight, but it's really a circle. So I'm going to go that way and I'm going to end up over there. And I go down there, I touch the end of the road, and then I drive down there and say, see, it's a circle. No, it's not. This is all he did. This is not circumnavigation. This is just a nice trip.
But again, that's not proof. That's all, basically circumstantial, right? And subjective.
What I'm saying is there's so many things that work. There's things that work on a flat earth, things that work on flat earth and a globe earth, like east-west circumnavigation. If circumnavigation to the south worked on a globe, it would have been done already, but it's been faked and it's been busted every time. Right. There's one guy that said he went to Antarctica and then he literally went from like here to here and then over to here. And then he got picked up and went like wherever he went. I forget the whole path, but again, they're exposed by their own data. So why isn't anybody doing that? Brian, have you seen any of the flight routes?
What do you mean flight routes?
So here's Buenos Aires. There's no direct flights to Cape Town. The way the flight goes is all the way up here and then all the way back down. That makes no sense on a globe. It should take 8 or 9 hours to fly from Buenos Aires to Cape Town. But instead it takes 29 hours because it goes all the way up to here and down. There's a little layover time in there, but there is no direct flight from Buenos Aires to Cape Town. It makes no sense on a globe earth, right? So I'll show you another one, which is good. Going from, is this it? Going from Perth to no, that's not it. Where did it go? I got it right here. So going from Buenos Aires to Perth, Australia, FlightAware says this would be the fastest route, but we're not allowed to fly over Antarctica because we will disturb the penguins. Okay. So let's go around Antarctica. The shortest route would be right around. Okay. That would be the shortest route, but that's not the route that the planes take. The route the planes take is this. They go from Buenos Aires to either Miami or Houston. Then they stop in Los Angeles. Then they stop in Sydney. And then they stop in Perth. Or they go the other way to Europe, to Singapore, and then Perth. Why don't they just cut across the bottom of the ball? And the answer is because that's not how the world works. The earth is flat, and those two places are at the opposite ends of the world pond.
Let's talk real quick because man, I like, you talk to a Glober there and they're like, no, there are direct flights from Buenos Aires to Cape Town. Look, they come up with their it's almost like their information versus our information. So let's cut to the chase on this thing. Aristosthenes, you had this guy, he's a YouTuber. He took his bike somewhere in this flat part in Canada. You said it was like basically a psyop, but what he did was he had this stick and his friend was 142 meters away or whatever. And he took his bike trip and he took his sundial and did the same thing. And he proved with math, he says that this proves right here that the earth is spherical, because if it was flat, you wouldn't have this, you wouldn't have
the difference in the shadows,
the variation in shadows. Correct.
Yeah. So this is absolute proof right here that this floor is spherical, because one of the bottles has a shadow and the other one doesn't have a shadow. So Brian, that is 100% proof that is a spherical flat floor.
Yeah, no, I see what you're saying. So what you're saying is he contends that the reason he got something different is because we're on a sphere and the sun is 93 million miles away. Your contention is no, the reason he got different measurements is because the sun's closer than he thinks it is.
Well, he thinks that the sun rays are coming in parallel because they're 93 million miles away, right, when nobody has ever seen a sun ray come in parallel. Now, Globers will say, well, the sun is coming in parallel, but then when it hits the atmosphere, it's being bent. Okay, it's being bent. That's why it's not coming in straight. Whether it's refraction, whatever you want to call it, it's not coming in straight. You're going to get different shadows over here and different shadows over there when you move, because the sun is small and local.
According to the flat Earth model, does the sun stay out, change altitude, or does it stay the same altitude all season long?
I think it stays the same altitude, but it might ramp up and go down. I really don't have any way to do that, to look at that. But
The
looking
reason
at
I'm asking,
go
wait,
ahead.
the reason I'm asking is because your last photo. Can you go back one photo? The last one you just had up with the sun rays
With
going
the
in
sun
different
rays.
directions.
Yeah.
Yeah. See the picture on my right? It says that has, if you think the sun rays were cast from 93 million miles away, see how they're not as angled as this picture to the left? You know
Sure.
what I mean? It looks like they're less angled than that picture that you see on the left. So that's why I was asking you about the altitude of the sun.
Yeah. I mean, again, I'm not there. I don't know what angle he was at the sun. So I don't know. I don't know. Maybe the sun isn't directly above that. That's the only opening in the clouds. I don't know. There's
Yeah,
so
that
many
is
variables. There's so many
yeah.
variables when you're looking up at the sky.
Yeah,
Um,
that's a curious thing to me right there. I don't know how to answer that question either. So what's your next
yeah.
slide?
So I don't think that the sun itself is again isn't in a we all see it in a different place. So like if somebody was out here, they're not going to see these light rays in the same place. Like when I look at the moon and it's lighting up only a couple of clouds, well, people that are farther away from me, those clouds are in a different position relative to the moon, so they see the moon lighting up some different clouds. We all see it based on our personal position. Again, it's things above our heads are we're speculating, we're doing experiments, we're trying to figure it out, but that's no way to prove the shape of the earth. Again, here's Eratosthenes, no shadow. You figure out the angle, do some perfectly good math, figure out the sphericity of this ball within 2%. He's the man. Most famous guy ever 2,000 years ago, but nobody decided to write about that story until the mid 1990s. Weird. Okay. But on a flat earth with a small sun, here's Eratosthenes, here's his buddy. They get the math, you get the same angles, do the same math, and it tells you the sphericity of this flat plane. Okay. You can have
Yeah,
math.
and how'd they do that, by the way, without direct communication anyway?
They had
wasn't the guy like
a string and a cup. They had two cups
string in a
and
cup?
a long
That's
string.
right.
Yeah.
That's kind of interesting too.
So it's again, and that's their big argument. And then we actually pushed them to the limit where Neil deGrasse Tyson on his stupid shill show addressed it, said, you know what? The flat earthers say it works on a flat earth. He's right. He goes, but it doesn't work with a third stick or a third well, right? He was showing you with 3 wells. And that's all he said. But it does. It does work with a third well. He just said it didn't. And the people go, well, it doesn't work with a third one. Well, no one's ever done it with a third one. And 2, if you model it, it works perfectly. So they say things with 0 proof. Okay. That's why I'm offering 2 Bitcoins for 1 proof of the globe, because you got none. You have none. There's none. Brian, I've been holding on to the Bitcoins for a while and no one's taking them. Nobody's taking them.
Yeah, but some people would say, well, nobody's taking them because you determined that it wasn't.
They're not even trying. They say photos of Earth. Photos of Earth. I'm like, which one? This one or this one? Okay. These photos are paintings. NASA admits that this one's a painting. And
truly they do.
This is a painting also.
Yeah, see, those are head scratchers for me. That's why I cannot. I can't argue with that. I can't argue with what you're saying right there. That's nonsense that they would have 2 different depictions of Earth. Yeah, look at that one right there.
Yeah. Well, the aperture and the temperature and they just make up excuses. They just go on and on and on.
Yeah. Okay. So let's see. Toxicosis says go up against this guy. Let's see. Logic of Science. Have you heard that guy? I haven't heard of him.
I haven't heard of him, but there are a team of these I call them just globe trolls. They're really filthy, disgusting, in my opinion. And they will just throw up nonsense and math. They go crazy with their numbers, and none of it proves anything. But there's nobody I'm interested in talking to.
Okay, so he says, so what this is 6 major problems with flat Earth. Number 1, the sun and moon. Many of the most obvious problems with flat Earth views revolve around the sun and the moon. So let's start here. For a flat Earth to work, the Earth clearly cannot be orbiting the sun. Neither can the moon be orbiting the Earth. Well, and neither of them can be very far from the Earth.
So let's hold all those questions. I want to go through every one of them.
Okay.
The flat Earth is not orbiting the sun. That's a false statement. They're saying it's impossible for the flat Earth to orbit the sun. They're right. We're not orbiting the sun.
Okay.
Okay.
Well,
So
no, they said for the flat Earth to work, the Earth clearly cannot orbit the sun. That's
it
what they're
does
saying.
not orbit the sun.
Yeah.
Correct.
For it to work, nor can the moon be orbiting the Earth. And you say correct on that as well, right?
Yeah, they're both circling over the Earth.
Right.
And the reason they set is due to perspective and atmospheric density. That's it. They're
Right.
small and they're close.
So he says to solve this problem, flat earthers argue that the sun and moon are actually very small, only about 32 miles in diameter. But you don't contend that, right?
No. Some people said they're taking that out of context, where a sun at I forget the height, but at 32 miles in diameter, at whatever height at 3,000 miles works the same. Yeah, it does. But it also could be smaller and closer. But also, we're not looking at it as a physical object in one place. We're looking at it as a projected thing. So there's more to it. It's way more complicated than that. But I believe that the sun is way closer than that.
Right. Yeah, you know what? I'm not going to go. Look, he goes through some serious detail. Number one is seriously.
Hit me up with because I know what they all are. Just hit me up with the idea of what he's talking about.
All right. The second one is gravity. Gravity is another huge thorn in the side of the flat earthers.
All right, let's talk about gravity.
And could it also be that he has the false idea of what a flat earther is? Because at the top of the show, you had said all these the flat Earth Society is completely bogus and kind of like a psychological operation, right?
Right. So let's talk about gravity. This is going to take a minute. This is worth it. So the sun and the moon are the anode and the cathode of the Earth free energy system, right? The salt water carries the current. The land is the salt bridge, okay? The Earth has a measurable, testable negative charge to it, right? In the air, as you move up away from the Earth, the voltage gets higher and higher. It's like 100 volts at 1 meter, and it goes up every meter from there, 200 volts, 300 volts. And there's all this voltage in the air. So when you lift something off the ground, it is attracted to the negative charge of the Earth. Okay. Mm-hmm. So the Earth says, hey, down is this way, and I'm not moving. Moving. Down is this way. And it's a weak force, just like they say gravity is a weak force. Buoyancy and density sort everything else out. If I had a handful of like tennis balls and rocks, and I dropped them over a swimming pool, they'd both fall through the air because they're more dense. The tennis balls would stay on top of the water. The rocks would go to the bottom. Mm-hmm. Buoyancy and density. Down is this way. Down is down for you. Down is down for someone in Australia. It's not up. Down is not up. Down is down. Up is up. Left and right, forward and back are all relative to your position. But that's what creates the downward force. And as I said, buoyancy and density sorted out. And then we can do tests that show us that this negative charge is something to pay attention to. You ever see one of these tinfoil things? You put a negative charge in it and it lifts off the ground.
Yeah.
It's not defying gravity. It's just defying the electromagnetic charge of the Earth.
Right.
Want to summarize another one?
Oh, did you want? Yeah. Let's see. Before we go to that, let's see. He says, assumption number one, there's a lot to unpack here, but let's begin with a simple question. How did they get those numbers? Talking about, well, it looks to me like he's talking in the context of Flat Earth Society. So I'll tell you what, I'll look over this stuff and I'll send it to you, and maybe we can do another show, which I'm sure a lot of people would like to see anyway. And you could just kind of pick this guy apart. That it'd be way better for you to do it than me to read it to you.
So let's talk about the sunset, because we haven't talked about that. And that's an important one. This is the sun over the high African plains, and it's a super clear day, no humidity, and you see it differently because the atmospheric deck of opacity isn't eclipsing it until it goes really, really far away. So this is clearly just going far away. So, but when you have an atmosphere that will block it sooner, here's how it works. That
thing you just showed, you never see that. That's very rare footage.
Well, there's actually a bunch of places that was in Africa. This is in Bulgaria, and the sun just clearly is going away. If you watch it now, I'm not claiming what size the sun is, because there's a lot of glare here. You put a solar filter on, you'll see a much more defined ball inside of here. I'm not talking about that. I'm talking about where's it going. Okay, is the Earth spinning underneath it, or is this focused point just moving away, appearing to get smaller due to perspective and atmospheric density. And as you see here, it's kind of just going to disappear into the atmosphere, and it's taking its light with it. It's a local light. It's not falling around the Earth, because if the Earth was spinning, it would get dark really fast everywhere equally. But in the southern hemisphere, there's a difference in the how fast it gets dark. Like here, this time of year, Brian, when the sun sets, how long is it light for you?
You mean here in Oklahoma?
Yeah.
What is it, like 13 and a half hours right now?
No. How, sure. Like after the sun sets, how long is it still twilight?
Oh, like 45 minutes to an hour, probably.
Yeah, sometimes like even like 90 minutes here, come June and July. And that's because the sun is small and close, and it's making us tighter circles, so it's staying closer to us. But out in the outer southern hemiplane, it's moving faster away. So when it gets to that point where it's right on the horizon, it literally goes away much faster. There's places in December, when the sun is out farther, like in South Africa and some places in South America, when the sun sets, 5 minutes later, it's pitch black. 5 minutes later. Well, how come we don't have the same thing at an equal latitude north? At 6 months later, we should have the same light effects, the same weather effects 6 months later in the north. So getting back to how the sun sets on a flat plane with the sun moving away. So here I call this my flat earth kitchen counter. This line here is level, right? And I'm moving my sun across the line. I'm filming it from a celestial point of view, from the height of the sun. Maybe like I'm on a balloon at 120,000 feet and there's the sun. Appears to be close to that same level. Now I have another camera on the table. So wait, this here is like a mountain, or I'll call this the atmospheric deck of opacity, but I never went below it. Now I'm filming it from the other end, cameras on the counter, and the sun looks like it's going down. Like if I showed you this first, I'd say, is that line level or is it going down? You would say it's going down. I'm going to zoom in even more. This is how we see the sun. You see this line? This is a level line. It looks like it's going down. And as it goes beyond this, it's not below it. It's just perspective. This line in the distance would look like it's a horizon, just like this. This is a real sunset. And look, this isn't the horizon. Oh, that's the atmospheric deck of opacity that it's going through. And I'm zoomed in on this. But if you looked at that, you wouldn't be able to see this space between this deck of opacity and this apparent horizon. They would be crunched together, and it would just look like the sun is setting behind it.
Yeah, and that reminds me, I mean, just kind of speaking to your point, there's some kind of island or some kind of mountain off the distance, like 126 miles away, and the sun supposedly is supposed to be, you know what I'm talking about?
You're talking about Mount Canigou. So from Illusia, France, this is a famous viewing spot.
There you go.
Because the sun out here is Mount Canigou, 175 miles away. And according to globe math, at this altitude, the top of the mountain should be over a mile below the ball horizon, which if you're a baller, you think this is the horizon.
Right.
But as the sun migrates in between the two tropics, there's a couple days a year where the sun lines up with this viewing point and Mount Canigou. Now, Mount Canigou, you're only seeing the light that is coming off of Mount Canigou, which is reflected from the sun. But it doesn't have enough power to push through the thickness. But the sun is much brighter. It can push through much farther. And it lines up with the mountain on these couple of days. And then it backlights them. Here's the top of the mountain right there. It should be a mile below the curvature. But it's not. And this proves it 100%. This is not a mirage. Now, a glober will go, the sun and the mountain are miles below the curvature. They're just refracting up.
Right. Which is what they say about the Chicago skyline when viewed from the other side of the lake, right?
I say to that, cool story, bro.
That right there, that's another one of those things that makes me go, what the frick? If those things are 175 miles, and there is a globe earth calculator, and those from that what is it? Some kind of viewing stand or something like that in France or whatever.
Yeah.
Yeah, from that viewing point with the globe Earth calculator, you should absolutely not be seeing the tops of those any part of that mountain. It should be a
And then
mile below the horizon. Yep,
and when the
like you
sun
said.
isn't lined up there and you can't see it, they'll go, "Oh, look, you can't see it. The Earth is curved." Brian, can you see my house right now?
Oh, no, of course not.
That's because the Earth is curved. I mean, that's globe logic right there.
Right. Well, that right there is
So
makes me think. Go
this
ahead.
is actual day and night patterns throughout the year, oscillating back and forth according to time and date. This is just a light changing its projection in over a glass dome. Kind of looks a little similar.
Interesting. So what am I seeing here on the right?
So
What is that?
so on right here, this is the animation of actual light and night. This dark part is night, and this
Right.
is day, according to time and date. And if you notice, watch the light wraps all the way around in December, right? And then it's less in other times of the year. So 6 months later. So this is the equinox when it was straight there. And as the light is moving in and out, the projection of the sun, this is how it works. So this is how people say there's a 24-hour sun in Antarctica. That proves that the Earth is a ball. Well, no, there's not 24 hours of sun. There's 24 hours of light. And that light is wrapping around the dome. When the sun moves out towards the dome, it wraps. So right here, watch, the sun's going to move out this way. Did it stop playing? No, it's still playing.
No,
So
it's so
when the sun's out here, it wraps around. It's called the coffee cup caustic. There, if you look that up, and this is a glass dome, and I got a little pen light right here, and I'm moving it in and out just a little bit in between the two tropics, and we get the same light patterns. That's got to be a coincidence, right?
Yeah, that's interesting right there. What convinces me more is not so much that experience, but actually what nature serves us up, which is that mountain that should be way below the horizon.
Right. Those are things that we can test ourselves. I mean, what got me, Brian, it was all these these boats over the horizon, things that we could see. And I said, okay. And I looked up the curve calculator and it said, okay, 10 miles, there should be 66 feet of curvature if your camera is right at the edge of the water, at the height of the water. But I'm 6 feet tall, so that's going to take 3 miles off of that. So I said, okay, I got a buoy that's off of my beach that's just over 11 miles away that I know. I've been there. I know how far it is. It's 11 miles away. Yeah. And so I bought a P900 super zoom camera, a little tripod. I got down, I sat right at the water's edge. I have the camera maybe a foot above the water. On a super calm morning, and I zoomed out. I could see the buoy, and I could see the surface of the water for dozens of miles beyond the buoy. Dozens. Okay? These are impossible things to see. And if you believe that it's refraction, you believe that the surface of the water is refracting up just to eye level, then stops. Let's refract up to here.
Right.
Okay? Right? That's insanity. Insanity. No boat. There's no boat here. I'm zooming in. And then all of a sudden, there's a boat. It has to do with the angular resolution limits of your eyes. I'm going to zoom all the way in. Now I'm going to zoom out like the boat's going away, and you're going to see it disappear from the bottom up. You think it's disappearing from the bottom up, but it's just the limits of your vision. And a glober would say that's over the Earth curve, but it's not.
You took that
This one I did. This one I didn't take. Someone else took this, but I have another one that's even better, which I don't have loaded in here. I actually did I just put it on my on the app? It might have been on the app recently. Brian, tell me what's going on here. This is the sun within the clouds. Clouds above it, clouds below it, clouds behind it, clouds in front of it.
Yeah, that's pretty crazy.
Pretty crazy.
Yeah.
And I'm not claiming to know exactly what we're seeing here.
I couldn't either.
Yeah, but it's not a ball 65 million miles away. And you know what? Think about this. When there's an eclipse, Brian, what does the government give you for free and warn you? Protect yourself. We don't want you to go blind. They give you those free glasses because they don't want you looking at an eclipse, Brian. Because when you see what's happening during an eclipse, it'll blow your mind. Let me share this. I showed you before, but I mentioned it. Let me pull up my eclipse video. You ready? So in the app, under frequently asked questions, if you click eclipses, up comes this, and So I'll explain what's going on here. And I've shown this a few times, but this is really good. So let me get everything out of the way here. So on the right is the eclipse that I filmed, the actual eclipse. The sky was a little hazy. And on the left, I'm creating an eclipse because nobody has ever seen the sun approach the sun or exit the sun. We only see this eclipse, but we never see the sun. So let me explain what I'm doing here. This is my paper towel sky, okay? And on the other side, I have a projector projecting a round sun onto the paper sky, and then I have a unlit circular object eclipsing the sun. So this is the object coming in. It's actually a juice cap, whatever, from a Snapple can. And I'm just moving it in. So you never see it approach. You only see something eclipse it. Just like here, I don't see the moon. I don't see the moon eclipsing the sun. So let me keep going here. And so this is, somebody filmed this in Michigan. And I think they caught the projector of the sun. So this is the eclipse. It's almost 90% eclipsed. It's blowing out the lens, but we see this and we see this. Now this is a lens flare because it's moving around, but this one is kind of locked into position of the sun. And why is it eclipsed like that? What are we seeing? I think we're seeing the sun is so dim, so eclipsed that we're able to see beyond it. And we could see the projector, just like you ever watch a movie projected onto a big sheet? And you can see the movie on the sheet from behind, the camera's behind. But if you look through the sheet, you can see the projector. You can see the light, the source. You know what I'm saying?
Yeah.
So I'm going to show you what happens here. So there's the eclipse. The eclipse is is exactly this amount. But what is this? How come we're seeing this? It's not a lens flare. And so what is it? And so I redid my experiment, but with a less opaque sky. Instead of using a paper towel, I use some tissue paper. And watch what happens when I do it. So I'm showing you, this is my eclipse. Now you don't see the moon because it's not lit up. It's not being projected into our reality. So there's the projector of the sun, and there comes my moon. It has no light. It's just eclipsing the sun. That's exactly what we see, the source of our projection, and then the sun that we see. So now I'm going to switch it to a more transparent, kind of like our sky, a more transparent screen, right? And here's what happened. So I got my more transparent screen. I got the sun projected on it. And here comes my eclipse from the left over there. And look, you have the same thing right there. That's the same thing that we saw. I'm going to compare it. And there it is. So I recreated the same thing with a projector. What do you think?
It's super interesting. Super interesting.
I'll take super interesting.
Somebody, let's see, Sammy Lee dropped an Injigini. She says, I don't care what shape the earth is. My focus is on God and family. This Dave Weiss is destroying.
Wow.
Destroying what, Sammy Lee?
Yeah. So let me address that. So first of all, I didn't believe in a creator until I understood that the earth was flat. Then I realized it's intelligently designed, and that gave me no choice to deny the creator anymore. Okay. So
how is that though? Because people with globe could say the same thing. It's like, man, we're spinning and we're rotating and we're revolving and it's all creation.
But there's also another option that according to science, a big bang, it happened and it's all by accident. So you have choices there. But once you understand the makeup of this earth is intelligently designed, and that we didn't evolve from pond scum, which is the dumbest thing ever. I mean, look at the complexity of our bodies, DNA, just all of this stuff, we are creations of God, of a creator. And now who God is, what your relationship is, that's your own deal. I don't tell anyone what to do with that. I have my beliefs. You can have yours, and maybe we're all right. Who knows? Yeah. So the fact of the matter is, the controllers of this world don't want you in a situation where you can deny the creator. They want you believing that you're a random speck from pond scum, flying on a speck in an infinite, godless, or distant God universe, spinning out of control. Asteroid could take you out. Nuclear bombs could take you out. Turn on the news. All of these things could take you out. This COVID thing, can take you out. They want you living in fear. They don't want you to know that you are at the center of creation, that you are important, that your thoughts create your reality. They want you to work your entire life away, where they take your spoils, they take it back from you. They literally want you working until you're too old and too sick to do anything else, and then they want you to die. They don't want you to know that nobody has dominion over you. So when you say, this is crazy and you want to focus on God, you're denying God's creation. Now, if you're a Christian, your book is a flat earth book from page 1. Read page 1. God separated the waters from the waters with the firmament. Okay. There's over 200 verses in the Bible supporting flat earth. There's 0 that support a globe, a spinning globe, a moving globe. There's verses that say the earth does not move. The only thing that you might assume is globular is in Isaiah. It says the circle of the earth. Well, my table's a circle and it's not a sphere.
Critical Inception says, if you teach your children we live on a spinning ball after you were given the option to study the truth, you are knowingly lying to your kids. Okay. Let's see. Wait, there was one more thing. Oh yeah. Can you speak to Operation Fishbowl? Because a lot of people don't know about Operation Fishbowl as well. And it is a thing. It was declassified. The military admits to doing it. What's your understanding of Operation Fishbowl, and what do you think they were trying to do?
So a lot of people say they were sending nukes up there. I think that was just what they told us. They were sending bombs up. This is Operation Fishbowl in 1962, as it say? 1962.
Yep, 62, yeah.
And they were trying to blow a hole in the firmament. So these are the 6 operations that they used to convince us that we live on a ball. They discovered the ice wall, Antarctica, Operation High Jump. Then they started exploring it, and they had Operation Deep Freeze, where they discovered the dome. And then they created NASA to to lie about us, to put the Van Allen radiation belts above us. Then the Antarctic Treaty, while everybody's fighting and killing each other, everyone agreed not to go out to Antarctica. Even though Admiral Byrd said that there's more land out there bigger than the United States, filled with resources, but nobody can go there. A dozen nations signed on. Now I think there's over 50 nations that have signed on, and nobody can question it until the year 2041. Okay.
Yeah.
You can get, Brian, you can pay.
That's strange too. You got to admit, that's very strange.
You want to go to Antarctica, it's going to cost you, tens of thousands of dollars. You go for a couple of days. They barely let you off the boat. They show you a little peninsula. They show you some penguins, maybe, and some icebergs. And they show you a ceremonial South Pole that you can't verify where you are because compasses don't work, and neither does GPS. Then they started trying to blow a hole in the firmament. I think Hillary Clinton was talking about that in her condolence speech, where she said, there's this glass ceiling over us, but one day, there's cracks in it. We're going to blow a hole through it. I think that's defying God's creation. Okay. This is all about honoring God. Flat Earth is all about God. And then they came up with the Apollo missions, where they, made us think that we can walk and live on a ball and fly through an infinite universe. And, there's aliens, right now they're priming us for the fake alien invasion. It's on every friggin' news show. Everything is all about UFOs and, they're disclosing, they're being forced to release. They're not being forced to release anything. They primed us our entire lives. They primed us forever to believe in this alien nonsense. Extraterrestrials, yes. From here on the Earth plane, they probably speak English. So
somebody said that I'm ignoring, guys. I miss 99% of what's in the chat room, so I'm not trying to ignore anybody. Who needs to be addressed in the chat room?
Type it in capitals, I guess, and let's answer any questions. I'm up for any questions.
Woken says Brian keeps ignoring him. I don't know who I'm ignoring. Unfortunate, guys. I'm not intentionally ignoring anybody.
Brian's trying to listen to me and read the chat.
Yeah. I just want to keep up with this. Helio Skeptic says Dave Weiss's YouTube channel. He posts a link. Thank you for that, man. Critical Inception posts Dave's channel. Thank you for that. Guys, we're just here to learn. No one of us knows everything, and none of us is greater than all of us. Just remember that. Just keep an open mind. That's all. Just Brian, open mind and hearts of compassion. That's all I ask. So what Woken, who am I ignoring, and what's the question?
Ask the question instead of complaining about it.
Okay, Woken says, anyone seen Virginia Galactic's first launch to space? Funny, LL, super fake. Brian, I meant Sammy, but I may have misunderstood. My bad. Oh, okay. Let's see. Dave, will you come on again? Because there ain't no way we have scratched a fraction of what you need to tell us.
Are we done? Are we over? Is it? We're
no. I'm just asking up front. Do you?
Brian, I'll do this bi-weekly with you if you want.
Awesome, man. Because I love you. You're my brother, and I don't see what you're seeing yet. You know, you've given me things to think about, and it's compelling. And some of the stuff that you've covered tonight has a better chance of swaying me than I would have been before we started this program. So, okay, what are you showing us now?
I'm just showing you, this is a weird anomaly that happens sometimes, and they go, it's ice crystals, but I'm showing you, they're seeing the sun manifest in 3 different positions. And again, compare this to the coffee cup caustic. I thought I had an image of it in comparison. It looks just like this. Amazing. Some of the optics of
that is great. How do they explain that? Has anybody attempted that? I've never seen that.
Yeah, I've actually seen this, and I just never filmed it. It wasn't. I saw this literally on a mountain just like this when I was snowboarding early in the morning.
What the heck?
Yeah.
Where was this taken?
This was, I'm not sure where this one was, but there's a whole bunch. A lot of them happen in Russia. It happens often in Russia.
Wow.
Yeah,
that is crazy. Okay, so give us a couple more things you want to show us about flat Earth in order to convince us.
A couple more things. We've been going over a lot of stuff.
Yeah, we have.
So we're going over NASA. Keep looking at the chat. Here's a little illusion. Check this out. Depending on where you focus, you'll see black dots in different places, and then your brain fills in the ones that you're not really looking at. It's just showing you how your mind is trying to make sense of this world.
Oh yeah.
And the dots will move. They don't move. They're in a pattern. But if you're looking at one, you can't see the others, and your brain will just fill in.
That's interesting.
Yeah. So again, the optic. How about this, Brian? Look at this. Are these tables the same size and the same shape?
I would say no.
Okay, but they absolutely are. Don't talk so it doesn't jump off the screen. There's a piece of paper, and then we move it. It's the same shape. Yeah, same shape. It's the same shape. It's just how our brains process this information. Crazy, right?
See, that right there is a demonstration of how ignorant I know that I am. Actually, I don't even realize the depth of my ignorance. That's crazy stuff right there. That is crazy.
And it's amazing. I actually didn't believe it when I first saw it. And where I got it, I printed it out. They give you the image, and I printed it out, and I cut out the little thing, and I did it. And it's crazy. Just let it go again. So don't say
do
anything.
It again.
So,
I was going to ask.
Yeah, here it goes, and up comes the paper. Move it, and then when you turn it, it's the same size.
Man, I love that stuff.
Yeah,
I love that stuff. That's really crazy.
All right. You know what's crazy? This is crazy. You think this is going on in Australia right now. Okay? This is crazy. And gravity's holding it all together. And down is down. Down is, and all of this is down. This is down. And this is up. Okay? This is up. This is up.
Yeah, I've never seen that demonstrated either. That's pretty
okay.
This
is ridiculous. All right. Yeah. This guy, he's got this cool flying pack, and he's doing it upside down to make it even more difficult.
That's funny. That's hilarious.
Yeah.
Wow. Question everything. Do you know, people are asking me if I should have Eric Dubay on. Do you know who Eric Dubay is?
Eric Dubay would be great if you can get him on. He just, sometimes he's a little antisocial. I don't know. Eric Dubay is the guy that was here first. He's smarter than me. He knows more than me. He just doesn't play well with others sometimes. But I think Eric is a fantastic flat earther, and I would love to see him on here. I would give up my spot on any show for him to take it. There you go.
See, that's what I love about you, man. You do play well with others, and you're not this flat earther that goes, well, if you don't believe it, well, you must be ignorant. You must have brains of crap.
Yeah. Here's your go fast rocket we were talking about earlier.
Yeah.
It went up and up. Now, if you find a good video of this, again, I believe it's on the app. I'm pretty sure if it isn't, I'll add it. And it went up, and all of a sudden it went kerplunk, and you literally hear it go into something thicker, like water, not maybe plasma, or in between water and air. I don't know. But the part I like about this the most is when it's an uninterrupted view, unlike NASA, cut. But when you can see the sky, you can see the moon. Here comes the moon. That dot is the moon right there.
Right.
Okay. The moon was over New Zealand when this took off. This was over where was it? Arizona. So if a basketball is the earth and Arizona is the top of the earth, this thing at altitude is a fraction of a millimeter over the ball.
Mm-hmm.
And New Zealand is underneath the ball. And we could see the moon that was over New Zealand. Sorry, doesn't work that way.
When this rocket did this rocket eventually lose altitude and come straight back down to the earth, or what?
It came down. I'm not sure exactly how far it landed, but I don't think it was very far. They literally got in their cars and drove and went to it. What's really amazing is when these balloons go up, or Felix Baumgarten with his.
That's what I was going to talk about next. Go ahead. Go ahead.
You bring up Felix. Why I.
Well, the reason I wanted to bring up Felix's jump is because you caused me to, you interjected a thought in my mind that I hadn't considered, is when Baumgartner went up, how long was he up there? Wasn't he up there for a couple of hours?
3.5 hours.
Yeah. And so if that's the case, you asked me, you said, Brian, if he was up there for 3 hours and the earth is rotating at 1,080 miles an hour, why didn't he come down? How could he have possibly come down where he basically took off?
Worse than that, Brian, the earth is spinning to the east.
Mm-hmm.
He should have landed 3,000 miles west of where he took off.
Yeah.
But he landed east of where he took off.
Right.
So he outran the spin of the earth.
Yeah, that's right. If he was up there 3 hours, then he would have been about 3,000 miles off of trajectory, right? Where he took off from.
And you know what I love is getting to the spin of the earth. People say, well, snipers have to calculate for spin.
Right.
For Coriolis, right?
Mm-hmm.
But hot air balloons don't have to calculate for Coriolis because they're spinning with the earth. They want their cake and eat it too, or whatever. I think you could have your cake and eat it. If you have your cake, why can't you eat it? Right. I hate that saying. So so balloons don't have to worry about Coriolis, but snipers do. Here's the question for you. How about a sniper in a balloon? Does he have to calculate for Coriolis?
That's a good question, man. I love that stuff.
A sniper in a balloon. I'm trying to find my Felix Baumgarten picture, but when Felix showed the Earth, it was a big curve. Oh, here it is. Here it is. So he's like, I saw the curvature. Now I used to say, okay, this whole thing was done to and he's a shill, and he said he saw the curvature, right? Mm-hmm. But I found out there was 2 test jumps they did before this, and I saw some of the footage from them, and they were all not using fisheye lenses, and everything was flat and level. But for the final jump, GoPro sponsored it or something with their fisheye lenses, and this is a fisheye lens because this is all New Mexico, right?
Wow.
Planet New Mexico.
Yeah.
Right. We can look at all these lakes and rivers and stuff. This is New Mexico. Hmm. Right. And he landed east of where he took off, which is crazy.
How high was he supposed to have been?
127,000 feet or somewhere around there.
127,000 feet.
127,000 feet. So divide that by 25 miles. Is that 25 miles?
Yeah, I'm about to do it. So you got 127 by 5280, right?
Right.
Yeah, just
25 miles.
Wait a second.
And so he said, I saw the curve. He might have been expected to see the curve, and he was wearing a curved helmet. He saw the curve through his curved helmet. You put a curved, glass over your face, you're gonna see the curve when you're on the ground. And there's a video. I gotta get the picture. But when he was getting into the capsule, there's a camera behind him looking out the door, and you could see the horizon right there, bisecting the circular opening perfectly. And then at altitude, when they opened the door, the same camera, same position, saw the horizon. And when you fade them together, the horizons are both at the same level. So 127,000 feet, the horizon should be so far away according to globe math, but it was right there at eye level. except for the fisheye lens.
Yeah, 127,000 feet is 24.03 miles. And you said that Go Fast rocket was 70 something miles up.
Yeah.
Yeah, and if you look back at the Go rocket, it didn't look like that at all.
Well, because it wasn't showing you a fisheye lens.
Yeah.
This is a fisheye lens. Flatten that sucker out, it's not going to look as high. This just looks high. This isn't that high.
Yeah, because the Go Fast rocket was 3 times higher than that Baumgartner jump right there.
Right.
Interesting.
Yeah. And if you watch like NASA footage, and SpaceX footage when they're showing the camera, the Earth bends, it's curved, then it's flat, then it's concave. It goes back and forth. It's unreal. What you see. Here's some shots at different levels, and it's always straight and level. And again, remember, we're seeing in a circle, so you can have the illusion of a curve, but it doesn't work that way. Yeah,
man. Thank you, Dave. I appreciate you coming on. Do you have any more you want to any parting words? Let's do
here's another one. So this thing goes 17,500 miles an hour. I think it goes up to 25,000 miles an hour. Okay, to get into space, right? This thing only goes 2,193 miles an hour, Mach 3.2, right? And if it goes any faster, it starts to rip apart. It doesn't have paint on it because the paint burns off.
Yeah.
But this hunk of junk can go multiple times faster. Come on.
Yeah, and the SR-71 is way more aerodynamic, and they have to design that thing to where the fuel tanks actually expand and contract. That's why it's leaking like a sieve.
And this thing can go 20. It can go so much faster. Okay, that's just perfect, complete and total insanity. Complete and total insanity. And getting back to NASA for a second, Werner von Braun, the story, Project Paperclip, the German scientist that was brought over to run NASA. You're aware of this, right?
Yeah.
So I actually don't believe the story at all, because I don't believe there was a space race. I believe that it was all stage fair, and Werner von Braun is just an actor. Okay. But with that said, he wrote a book in 1957 called Project Mars. And it's about a bunch of people that went to Mars, run by a guy named Elon.
No.
Still available on Amazon. They just changed the cover, but look at the rocket. Look at Elon's rocket. Do you see a similarity?
Wow.
Worse than that, a month ago, Elon tweeted, "I want to redesign my rocket and make it pointier." Okay. This is mockery.
Now we could say that the parents of Elon Musk read Werner von Braun's book, and thus named him like that.
Good one. You're global apologist. Cool story. I'll put on my glasses. Here is the.
You don't think that's a possibility that Elon Musk?
You know what, Brian? I'm gonna give the globe every option, because it doesn't matter. Like
I'm not arguing for globe. I'm just saying they could have read that book and named Elon after the character in his book.
I highly doubt it, but I won't rule it out. And it doesn't matter. When I went out to look at that buoy, the curvature calculator said 66 feet of curvature. Okay, and I'm rounding down from 11 miles to 10. So. But some globers will go, no, that doesn't matter, because they're both over the curve, so it's only half of that distance. Okay, 33 feet. All right, the buoy's only 6 feet tall, if it's that, and I can see the entire thing in the water behind it. Even if you just give them every inch, every doubt, everything, every bull crap claim, it still works in favor of the flat Earth. Right? Mockery. A spacecraft flying by at 60,000 miles an hour took this picture of Pluto, okay? Right, with a distant sun. The sun is a tiny little dot. How did it get this perfectly crisp, beautiful picture with a desert kind of shaped like the dog Pluto, which was created the same year that they discovered Pluto, apparently, okay? How many coincidences do you need? How many?
Got another one?
2 different pictures of Saturn 2.5 years apart. Saturn of Jupiter, which is a gaseous planet, and none of the clouds moved. None of the clouds moved.
And they're supposed to be moving at like hundreds of miles an hour, right?
This storm, this is a hurricane bigger than Earth, and it's going. Here's a couple days time lapse of a probe that supposedly went to Jupiter. All right, plenty of movement. Okay.
Yeah.
Plenty
Is
of
that
movement.
is that fake? Is that fake imagery right there?
No, well, it is fake, but it's from NASA claiming it's real.
Hmm.
It's from NASA claiming it's real.
Yeah. Interesting.
Yeah. Amelia Earhart, circumnavigation. Here's her trip. Circumnavigated east or west. She just went around. Nice big circle. She circumnavigated the flat earth pond. Flat earth pond. And Brian, they control our minds with cartoons.
And Photoshop has made it that much easier, huh?
And they've made it that much easier. Hey, for those of you that want the app, point your camera here. It's the Flat Earth Sun, Moon, and Zodiac Clock app by Blue Water Bay. There's already a Flat Earth Society knockoff by, I forget the name of the company they have. They stole my graphics. They stole the name, but the app sucks. If you get it, don't send me an email telling me my app sucks because it's not my app. All right. My app is the highest rated app in Google Play and the highest rated app in the App Store. Everybody loves it. Read the reviews if you're unsure. You don't have to get the app. Just go to theflatearthpodcast.com. Plenty of information there. But the app's a lot of fun, and it's the best way, when you're stuck in traffic or sitting on a train or just bored or whatever, break out the app and tons of information. And you'll find this interview on there too, probably tomorrow.
Living Soil says, I've had the app for years. How do you like it, Living Soil? People that I've talked to that have the app, I've never heard one complain about it. They love it. They love it. All right. Hey, Dave, thank you for joining us. I really appreciate it. Stand by, okay? Because I want to talk to you. Guys, thank you very much for joining us. I will see you in the next D Live. Thanks for hanging out. And we are going to have Dave Weiss back. Dave Weiss, thank you very much. Somebody, please, one of my mods put Dave Weiss's YouTube channel. And what other links? Are you on Twitter? Or are you on Instagram?
So I'll give it to you. My Instagram, my Facebook page, which I'm in jail for 2 more days, and my website is The Flat Earth Podcast, and my podcast, The Flat Earth Podcast, and theflatearthpodcast.com. And then my YouTube is just DITRH. It's the initials for Deep Inside the Rabbit Hole, DITRH. But if you get confused, theflatearthpodcast.com, all the links are there, including the app. And check out the app if you want to support me. But the app, I look at it, the app is cheaper than a good cup of coffee or a half of a beer. It's about a half of a beer, and you have it forever. You don't pee it away. You have it forever.
All right, man. Thanks, Dave. I appreciate it. Thank you, guys. Appreciate you joining us. I will see you guys at 6:30 p.m. Actually, 6 p.m. Central Standard Time on Thursday. Take care, guys.
The Flat Earth Sun and Moon Clock app, a dynamic new app to teach family and friends about where they actually live. The sky is a perfect clock. The sun measures the hours and days. The moon measures the weeks and months. The star constellations measure the seasons and years. 12/12 or 24-hour clock face, or go hands-free. The Flat Earth Sun, Moon, and Zodiac Clock app with new added features. World Time. See what time it is all around the flat Earth. A true Earth compass that shows true navigation across and around the flat Earth plane. Weather. Tap for detailed local weather information. Know what phase and where the moon is at all times. Watch the sun travel between the tropics for the seasons. Select an amazing background. Add your own or have the app change it to a new one automatically every time you use the app. Add a countdown to your next big date. Learn the truth about our world with the featured video of the day. Web button for additional flat Earth related features, from the mythical curve calculator all the way to Tartaria. While talking to friends, easily pull up pictures that expose the globe lie and shine light on the flat Earth truth. Video playlists in different languages. See the real trade winds circling the flat Earth, and clean screen features. Simply click off the items you don't wish to see. The Flat Earth Sun, Moon, and Zodiac Clock app is the best tool to show your friends and strangers how our flat Earth actually works.